Welcome to my talk on OpenTelemetry for Java developers. Few words about me. So who am I and why am I here talking about OpenTelemetry? So my name is Fabian. I work for Grafana, where I am manager for our instrumentation teams in the application observability department. I'm also an active open source contributor, so I'm a member of the Prometheus team, where I maintain the Prometheus Java metrics library. So this talk will mostly be demos. This is what I got running on my laptop. So basically we have a couple of Java services, and this talk will mainly be about how to instrument these Java services with OpenTelemetry. Then I have the OpenTelemetry collector running. So in case you don't know what that is, it's basically an open source project from the OpenTelemetry community. It has a standard port open, and on this port it accepts metrics, distributed traces, and logs, and the Java applications send their telemetry data there. And then I configured the OpenTelemetry collector to forward metrics to a Prometheus database, and to forward distributed traces to Tempo, which is an open source trace database, and to forward logs to Loki, which is an open source log database. If you want to have a look at that demo or any of the code examples that I'm going to show, I pushed everything on my GitHub repository here. I also have the link on the last slide, so if I'm moving too fast now, you have a second chance to take a picture of that. So let's move on to the Java application. So this is the example I came up with that I'm going to use throughout the demo. So it's a Hello World REST service. Basically, you send a request to port 8080 and it responds with Hello World. But in order to make distributed tracing a bit more interesting, I made it a distributed Hello World service. So instead of responding directly, it reaches out to a greeting service, which is running on port 8081. And the greeting service produces the greeting, which is Hello World, and then the Hello World application forwards that to the client. So it's basically a microservice architecture for the Hello World REST service. Okay, and for this talk, I've thought a bit about how to structure it, because I'm going to show you different APIs, different implementations, different ways of doing things, but I ended up structuring it signal by signal. So what we are going to do, we are going to first look into metrics, then we are going to move on to distributed tracing, and then we are going to move on to logs, right? And for the metrics part, we will basically look at Spring Boot 2. The first thing we are going to do, if you have a standard Spring Boot 2 application, no instrumentation at all, but attach the famous OpenTelemetry instrumentation agent, what do you get out of the box? And then we will look at, if you extend this with custom metrics with the OpenTelemetry API, how that works. And then, as you might know, Spring Boot 2 also has a metrics library built in. You get that if you enable the Spring Boot actuator, and we will have a look, how does that play with attaching the OpenTelemetry agent and how do things fit together. In case you're not a Spring user, but maybe using Quarkus, the underlying implementation in Spring Boot is actually called Micrometer. That's the metrics library, and that's used in Quarkus as well. So I think things will be very similar for Quarkus. And then we look into distributed tracing, and there's news with Spring Boot 3, everything changed, and we will look what's new there and so forth, and then move on, right? Anyway, we start with metrics and Spring Boot 2. So let's move on to the demo. So this is the greeting service, the example I implemented here. I hope you can read this, otherwise I need to switch to light mode. I could also do that, but I guess it's dark enough here. So what it does, plain REST service as you would expect. So if the /greeting endpoint is called, the first thing I'm going to do is I'm logging a line. So that's basically for later when we look into logs, so that we have some log message to look into. Maybe a few words about that. So often you see in applications that somebody just logs the same message over and over. If you know a bit more about monitoring, you might reconsider this, because logging is relatively expensive. You know, you need to store all these messages in your log database. In many cases, it's a lot better to just have a counter metric, for example, counting these types of events and so forth. So we will show you a couple of examples in a minute, and maybe later, if you think about it, if you have log lines in your code just repeating the same message over and over again, maybe a metric would be better, maybe a trace attribute, whatever. So there are other ways of doing things than just logging the same line over and over again. Anyway, after that, I sleep for a random amount of time. I sleep again for a random amount of time. And then in 30% of the cases, or I guess 20% of the cases, that's a strict less than, I throw a random exception just to simulate an error rate. But in most cases, I just return hello world. So, and the first example we are going to look at is what happens if I just take this application as it is and attach the OpenTelemetry instrumentation agent. In case you don't know what this is, it's a GitHub project. It's here in the, let's make it a bit larger. If you go to the OpenTelemetry GitHub, there's OpenTelemetry Java instrumentation. You can click on the releases page there. Where is it? Up here. And then you would download a file named OpenTelemetry Java Agent jar, right? And what you do then, I actually have a slide about this. It's not difficult. You download it. The first thing, the only thing you need to remember, it's always great to set a service name, right? So the service name will become part of your metrics, of your traces, of your logs. And if you configure a meaningful service name, it will be easy for you to understand what service you are looking at right now, right? There are different ways to do this. In my example, I just used this environment variable, OTL service name, and just use something so that I know which example I'm looking at, right? And then you start your Java application as usual, but with this special command line parameter -Java agent, and then the path to the OpenTelemetry jar, and bam, you get metrics, traces, and logs. That's cool. And as my collector is running on localhost on the standard port, I don't even need to configure that. That's the default. If you run on another port, that's also environment variables for that. Cool. So let's look at these metrics. There are actually a lot of metrics coming out of that, you know, garbage collection activity, whatever. The one I'm going to focus on in the example is called HTTP server duration. And that gives you information, you know, about your REST service invocations. This is the Prometheus representation here. So in the type of this metric is a histogram. And in Prometheus, you recognize that because it has a couple of time series. It has a count, counting the number of requests, a sum, and it has histogram buckets. And if you just look at an example for my service, let's use this one, for example. Yeah, it looks like this. Maybe make the time window a bit smaller. So basically, if we just look at the count part of the histogram, it counts requests, right? So we see a green line here representing HTTP requests that result in status 200. So these are the good cases. Yellow line is HTTP status 500. These are the bad cases. And actually, I could now jump into showing you a couple of Prometheus queries and how to use Prometheus to make something useful with that kind of data. But in this talk, I want to focus more on Java APIs and how to instrument your application. So I'm not going to turn this into a Prometheus tutorial, but just to give you an idea what you can do with such a histogram, I created an example dashboard. Here it is, OpenTelemetry HTTP metrics. That's basically just a couple of queries running on that data here. Let's pick the last 15 minutes so we see a bit more. One thing you can do based on these counters, you can calculate a request rate, so you know the current load on that system. So we see here we currently get 0.25 requests per second coming in. You can calculate the error rate, which is basically number of requests with HTTP status 500 divided by total number of requests, right? And we see it's around 20% as expected from our code, right? And then you also have the histogram part of it, which represents latencies. You can just visualize it as an actual histogram, and then you see that there is this peak here between 100 and 500 milliseconds, so that's where most of my latencies are. You can also use this nice Prometheus function called histogram quantile to generate quantiles out of that. So this here, the green line is the 95th percentile. So that basically tells you 95% of the calls have been faster than 475 milliseconds. Only 5% of the calls slower than that, right? Yellow line is the median, so half of the calls faster than that, half of the calls slower than that. And the cool thing about these examples is that everything you're seeing here is really just visualizations of this single histogram, HTTP server duration. So that's all that's needed, right? And this is pretty standard in all of OpenTelemetry's instrumentations. So whenever you instrument a REST service, you will be able to configure such a basic monitoring dashboard, and that's even like that's pretty good already. So that's better monitoring than most people have out there, right? If you're wondering about these little dots, that's a feature of the OpenTelemetry data model. It's called exemplars. These are basically links to example traces, right? So if you've got a couple of examples for particularly slow calls or particularly fast calls, and if you're interested in seeing like how can a call be so slow, then you can go with the mouse over it, query it in tempo and watch your trace. But yeah, let's do tracing later. So that's the metrics part of the talk. Cool. So this was out of the box without any code modification. And as we can see, so from the technical metrics, latency numbers, request rates, error rates, that's already quite good. But general advice, if you want to do monitoring, it's always a very good idea to also expose information about what's going on in your business logic. That will be really helpful if you have an incident, if you want to figure out what happened. Any information that you get about what your application was actually trying to do will be helpful in the future. And so throwing in some custom metrics about your business logic is always a good idea, right? And so, for example, let's say this was a payment service, right? If you just have a simple counter with payment type as one attribute and whether it's rejected or accepted as another attribute, then you can immediately see, oh, my system became slower, but at the same time, all PayPal payments got rejected. That's a lot more information than just this technical, my service got slower, right? So, and the first example I'm going to show you with custom metrics is using the OpenTelemetry API. So the OpenTelemetry project has this agent that you can attach to your application without modifying code, but it also has an API for custom metrics. So basically, if you want to use that, you use this dependency here. It's OpenTelemetry API, and then you're good to go. And I'll show you a quick example. So I added a little counter to this service just to show you how that looks like. The starting point for the API is always this global OpenTelemetry.get. And if you attach the OpenTelemetry agent, it will hook into that and then basically learn what custom metrics you have and combine them with the out-of-the-box automatic metrics and then expose them all together, right? And then there's a bit of boilerplate. So I'm basically creating a counter named my custom counter. And then down here, whenever my greeting service is called, I increment it with some example key and some example value just to show you an example, right? So that's of course useless. It basically just shows you how often the endpoint was called, and we know that already, but just to show you an example of the API, right? And so if we, how did I call it? My custom counter. So if we go to Prometheus, we should be able to see this. So let's switch to the Prometheus data source, my custom counter. Here we go. A counter counting the number of requests, always increasing at 0.25 requests per second. And here is even my Fabian's custom key example value and so on, right? And now you can, of course, use PromQL and say, okay, how often does that happen per second? Include that in your dashboards and give you some information about your business logic. Cool. So that was OpenTelemetry. Let's go back to this overview slide. So that was basically the first line. What we had the Spring Boot 2 application, And we attached the Java agent, looked at what's coming out of the box, and then I showed you if you want to use the OpenTelemetry API to extend this with your custom metrics, how you would do that, right? And now you might already be thinking, and I also said this in the introduction, Spring Boot has its metrics library built in. So everyone who has used Spring Boot Actuator knows that. So maybe you even are using it for monitoring now, or maybe you even have used that for your own custom metrics. And now the question is, what do I do with that if I want to switch to OpenTelemetry? And there's good news. The OpenTelemetry Java agent actually recognizes the Spring Boot Actuator. And if you are using Spring Boot Actuator, then all the metrics that are coming out of the actuator will be picked up by the OpenTelemetry agent and included together with the automatic OpenTelemetry metrics. So you will basically see them both, which is cool. So let's show an example. And it's also interesting because it gives you some duplication, and I'm going to show you an example of that now. So here's how this works. Spring Boot Actuator is just a regular, dependency, Spring Boot Actuator starter, and then you are done. There's one configuration that I always recommend. So the Spring Boot Actuator gives you a metric named HTTP server requests. And there are different representations, and I think it's great to have this represented as a percentile histogram, which you can do with this system property here. So that's configuration I always recommend. And if you do this without any additional code and you add the OpenTelemetry agent again, then the OpenTelemetry agent will pick up all the automatic metrics coming out of the Spring Boot Actuator. So I can show you this HTTP server requests example now. So if I search for HTTP server requests, here we go. It's a histogram. Maybe I think I have it multiple times. So let's use the Spring Boot 2 example here. It's again a histogram. It has a count, it has a sum, it has histogram buckets and so forth. You see again a green line for the good cases, HTTP status 200, yellow line for the bad cases, HTTP status 500. And actually the contents of this metrics, of this Spring Boot metric is very similar to the metric that we have seen previously. So if you remember, the one previously was called HTTP server duration, and this one here is called HTTP server requests. So basically OpenTelemetry and Spring Boot have different names, but the semantic is very similar. And actually, to show you how similar it is, I recreated the dashboard that we have seen before, but this time not using the OpenTelemetry metric, HTTP server duration, but using the micrometer metric instead, or the Spring Boot metric, which is called HTTP server requests. And if you look at this example here, doesn't matter which one we choose, they look the same. It's the exact same dashboard. We get the request rate, we get the error rate, we get a histogram showing us the latencies, and we can also derive percentiles out of these latencies. So that's actually interesting. I guess in practice, you would need to decide which one to choose, right? So the main difference is that if you look how this dashboard is configured, the underlying Prometheus queries basically use a different metric name. So in this case, HTTP server requests instead of HTTP server duration. So the question is, of course, which one you would choose, and this will be the conclusion. So we look at traces and look at other things, and then we come to a conclusion which one is good for which case. But once you have chosen like which one you want, it's probably, you don't need the other one anymore. It just costs you time and space, and so it's probably good to disable the other one. You can do that. So the OpenTelemetry agent can be configured via system properties. So if you decide you go with the OpenTelemetry HTTP server duration, you can just disable micrometer, say micrometer enabled false, and then you won't see these micrometer metrics anymore and won't be confused, It also works the other way around. If you say, I'm going to use OpenTelemetry agent, but mainly for tracing and logs, because for metrics I want to use what's coming out of Spring Boot, then you basically disable the default instrumentations by the agent and enable just micrometer and just the Spring Boot actuator auto configure, and then you will only see the micrometer metrics. Yeah, so that was out of the box example. And before I wrap up metrics, I want to show you a quick example. If you're using the Spring Boot actuator library, of course, if you want to start introducing custom metrics, you can now do that with Spring API. So you don't need this external dependency to OpenTelemetry API. You can basically just use Spring's own framework. This is, of course, very well integrated into how Spring works. So the entry point into Spring Boot actuator is this thing called meter registry. The Spring framework will provide the right meter registry via dependency injection. So I'm using constructor injection here, and Spring will just give me the right object. And then just to give you a simple example, I'm just created a counter. I just say whenever my greeting service is called, registry, give me a counter, name it greetings total, and increment it. And that's basically it. This API is pretty rich. So first, it's Spring, so for everything there's annotations as well if you don't want to do it in code. And yeah, it has a lot of options, and it's a pretty good API, right? And if I do that, greetings total, that should of course be available then in Prometheus as well. Let's try this, greetings total. Yeah, again, in this case, it's basically just counting the number of requests, so not very interesting, but you can imagine if you have some real business logic and want to count whatever is really happening in your business logic, or have some timers, you know, measuring latencies around things happening in your business logic and so forth, that can be very valuable. Cool. So that was the metrics part. So the start, we stick with Spring Boot 2 for the metrics. Hui, calendar event, nice. We stick with Spring Boot 2 for the metrics, attach the OpenTelemetry agent, and then showed you a couple of ways how to extend the out-of-the-box metrics with API, with custom metrics, using OpenTelemetry API, using Spring Boot way, and so forth, right? So now, if we move on to distributed tracing, things change. And the thing is that Spring Boot 2, of course, is relatively old, and when it was created, tracing was probably not as popular as it is today. And so the Spring Boot actuator that is part of Spring Boot 2 is only a metrics library. So micrometer in Spring Boot 2 is metrics only. So if you want to do any tracing, you need other stuff as well. And of course, the most straightforward thing is attach the OpenTelemetry Java agent, then you get tracing out of the box. And again, it's good to extend your traces with annotations representing what's happening in your business logic, and I'm going to show you how to do that, right? With Spring Boot 3, things changed. You can still attach the OpenTelemetry agent to Spring Boot 3, and it will also work, so that's fine. But Spring Boot 3 also comes with a complete re-implementation of the actuator or of the underlying micrometer library, and it's now no longer just a metrics library. It's basically a combined library for metrics, traces, and there are OpenTelemetry logs appender, so you can get all OpenTelemetry signals completely just with the tools built into Spring Boot 3. So you don't need to attach the agent anymore. And that's particularly interesting because, as you might know, so there was a talk about that on Tuesday as well, you can compile Spring Boot 3 applications to native mode and run them without a JVM at runtime. And if your plan is to do that, of course, without a JVM, you cannot attach a Java agent. So this whole process of downloading a Java agent and attaching it to a JVM at startup time, that works as long as you have a JVM. But as Spring Boot is moving to this, at runtime, I'm without a JVM as just a native executable, this wouldn't work anymore. And therefore, it's really cool that it's also not needed because Spring Boot 3 has complete OpenTelemetry support built in. And I'm going to show you how this works. So, but let's start with Spring Boot 2. So the first example I'm going to show you is again just the unmodified Spring Boot 2 application, OpenTelemetry agent attached, and we're just going to see what do the traces look like that we get out of the box, so that you see an example of that. So let's switch to Tempo, which is the open source trace database that I'm using here, and let's just select whatever, any of the 2 examples. Let's try and find a trace. This one looks good. Maybe close the search window here. Okay, so this is how it looks like. I'm not going to go too deep into that because I think at this point most people will have seen tracing before somehow. I don't know, but basically the lines represent what's happening in an application, right, or in a service. Different colors are for the different services. I think they are chosen automatically at random or something. Now it's dark green for the Hello World application, light green for the greeting service. I don't know why. I hope you can still see the difference. But basically the first line here represents the HTTP request that is coming into the Hello World application, right? And then the second line represents the Spring controller handling that request, right? And the third line is the outgoing HTTP requests sent by the Hello World application to the greeting service. And then we switch colors, then we are at the greeting service, and again we have a line representing the incoming HTTP request, we have a line representing the Spring controller handling the request, and then our distributed processing is done. And of course all of these spans, as they are called, have metadata associated with them. So if we open an example of an HTTP span, we see HTTP attributes like the path that was queried, or status code should be somewhere, and stuff like that, right? And if we look at a span representing a Spring controller, we see interesting stuff like the name of the controller class and of the controller method. And of course, that's always like resource attributes showing how the JVM was started and so forth. So you get some additional information what's like associated with these spans. Cool. And now distributed tracing is already quite cool. I mean, if everything goes well, you don't need it, but as soon as you have some exception somewhere down the stack and you want to figure out where and what went wrong, or if something takes longer than expected and you want to understand where you lose all the time, it's pretty handy. But it becomes, as with metrics, it becomes a lot more valuable if you start extending this with some insights what's happening in your own business logic, right? So if this is whatever, a payment service, and you just add a simple span attribute saying, this is actually now a credit card payment, or this is now a PayPal payment, or whatever, right? Then later, when you look at traces that took long, you can see that, and you can see, okay, actually the long-running traces are always related to credit card, and that's a valuable hint, right? Or if you are debugging something and want to see an example of a credit card payment, you can search for these attributes, and then you will find a span immediately representing what you're interested in, what you want to debug. So exposing stuff about your business logic is always a great idea. And of course, you can use the OpenTelemetry API to do that. So that will be the next code that I'm showing you. OpenTelemetry custom. Here we go. So the dependency, as before with the metrics, still the same OpenTelemetry API. And I played a bit with the tracing part of that. So what we have here is again our greeting service. We have our first sleep here. We have our second sleep down here, and between those two sleeps I'm playing a bit with the API. So one thing I'm going to do, I'm going to add an event. So event, in my case, it just has a name. Event can also have metadata and stuff. So basically an event showing me that the first sleep ended now and the second sleep is about to start, right? I'm also annotating the current span with a custom attribute, which I just called Fabian's attribute key with some example value, but that's how you would put information, which path in your business logic you're in, right? And I'm creating a custom span. I'm starting it before the second sleep, and I'm ending it after the second sleep, okay? And if we look at how that looks like in your favorite tracing tool. Traces custom, so that should be the right service. Let's try and find an example. So this one's looking good. Close the search window. So now apparently the color for this version of the greeting service is orange, but I think that's random. Now what we see here, there's a little line here, which is the event. So that's basically showing us exactly the point in time when the first sleep ended and when the second sleep starts. So you can also see the event here if you look at the details of the trace. So that's where it is, right? We added a custom attribute, of course, that ends up here, Fabian's attribute key with example value. And as said, if you are interested in these particular types of spans, you can search for that and so forth, right? And finally, we got the custom span down here, just representing my second sleep. So I can see immediately how much time I spent in my second sleep. So yeah, just a stupid example to show you a bit of the API, but it's definitely like if you use tracing a lot for debugging your applications, exposing information about what's going on in your business logic is always a good idea. Good. So that was again Spring Boot 2 standard, OpenTelemetry API, how you can do these things. And now, as promised, the new thing that came with Spring Boot 3, the new micrometer implementation that's used in Spring Boot Actuator there. So how are you using this? Actually, so let's go here. Actually, it is a little bit, I don't know, you need a couple of dependencies to set this up. And in order to make it a bit easier, we, as Grafana, we created a very small open source project named the Grafana OpenTelemetry Starter. So that's also available on GitHub. It's here, Grafana OpenTelemetry Starter, right? If you are interested in how exactly it configures your Spring Boot application, you can read the code. It's not much code, but it's kind of simplifies your POM a bit because you just add this starter and you are done. You will get OpenTelemetry support in your Spring Boot 3 application, right? Configuration-wise, there is, again, this property that we used in Spring Boot 2, telling that my HTTP server request should actually be a histogram. So that's something I always advise if you want to use that for Prometheus dashboard for monitoring REST services. And then you somehow need to set the application name. There are different ways to do this. I just set this Spring application name system property here. And so this application name will be used in my OpenTelemetry data. Okay. And yeah, if we just run this now out of the box, we will see the out-of-the-box metrics, which are the same that we are used to from Spring Boot 2, still micrometer metrics, still same name, but now with built-in, now Spring can just ship them directly with OpenTelemetry. You don't need to attach the agent anymore. And we will also see traces. And for logs, you need to do something actually. So you need to configure your log framework to use this OpenTelemetry appender. That's actually, if you go to the Grafana OpenTelemetry Starter, there are snippets how to configure it. So if you are using logback, you basically configure that snippet here. If you are using log4j, then you configure that snippet. But all it does is basically just telling your log framework that it should use the OpenTelemetry appender. Okay? Yeah, and that's the last piece missing, but then you will have metrics, traces, logs out of the box in OpenTelemetry format, out of Spring Boot 3 without any additional agent that needs to be attached, right? Cool. And now, of course, the interesting part, how does the new API look like? And that's actually cool. That's a pretty innovative idea. So if you remember in the metrics example of Spring Boot, the starting point was the meter registry, which is the metrics thing. Now Spring Boot 3 has a new thing called the observation registry. Again, it's provided by the Spring framework via dependency injection. I'm using constructor injection here to get my right registry object. And I played a bit with the API here. So I'm creating a new observation, calling it Fabian's observation, right? then I'm starting the observation, then I do my first sleep, and then between the two sleeps I add an event to my observation, then I do the second sleep, and then finally I stop my observation, right? So this API is actually super rich, so you can do a lot of stuff, and I just wanted to show you one example, but it's by no means complete. And also, as it is Spring, there's annotations for everything, so if you just want observations around specific methods, you can just annotate the methods and so on. So there's a lot of things you can do, right? But just looking at this simple example, so the cool thing is, of course, this generates traces, as you would expect. So if we go again to the search window here, search our Spring 3 example. Where are we? Here. Is that? Oh, that's actually one with an exception. Shall we look at the exception? I don't know. Well, maybe that's interesting. So what I actually wanted to show you is the Fabian's observation. So that's represented as a span here, Fabian's test observation, right? We also had this event in the middle between the two sleeps. That's now here, Fabian's test event, as you would expect, right? I accidentally opened one of the examples where an exception was thrown. So that's why you see a little red thing here. Maybe I can show you this as well. So if an exception is thrown, you basically get an event attached to the current span when the exception happened. And if you look at the data from the event, then you see the stack trace attached here. So you can basically immediately navigate to the line of code where this exception happened. But that's the same with the OpenTelemetry agent. So if an exception is thrown, or an unhandled exception is thrown while you're processing a REST request, you will always see an event represented in the corresponding trace, and you will always get this highlighted as with this red symbol here. Anyway, but that's not what I wanted to talk about. I wanted to talk about the API actually, and what we see here is my test observation with my test event and so forth. And the cool thing about this API is, as I said, it's a combined tracing and metrics API. And so what it will do, it will not only create these spans, it will also create corresponding metrics for that. So if we switch back to Prometheus, which is the metric database, and search for observation, we see that there's a whole lot of observation-related metrics that were created, right? There's Fabian's observation, kind of a histogram with histogram buckets and count and so forth, the time, how long my observations took, and I can get some overview, 95th percentile and so forth, right? There's also a metric representing my event, Fabian's observation, Fabian's test event total, long generated name, but if you click on it, it's basically does what you think it would do, counts the number of times that this event happened and so forth. And I think this is a pretty cool feature because if you get metrics along with your traces, then you can not only use your traces when you debug and look at a specific trace, but you can also take these metrics, create dashboards, figure out how often per second does this event happen, start, creating alerts and so forth. So this, combining metrics and traces behind a generic observation API is a pretty cool idea. So, okay, so that was Spring Boot 2 with the OpenTelemetry agent. Of course, you can also use Spring Boot 3 with the OpenTelemetry agent, so it would just look the same as Spring Boot 2. But I also showed you the new thing in Spring Boot 3, this observation API that's with the new Spring Boot actuator, and how you can use that for complete OpenTelemetry support. Logs are missing, and I'm not going to spend too much time on logs because they are exactly the same for all options. So you need to enable them. I showed you already in Spring Boot 3, you need to configure this OpenTelemetry log appender. If you're using the OpenTelemetry agent, you also need to enable it because it's currently not yet marked as stable, so it's not enabled by default. You set an environment variable saying I also want to see logs, and then you see them. If you do this, it's the same for Spring Boot 3, Spring Boot 2, whatever combination. If you just look at whatever one of the examples, show logs, it looks like this which might be a bit confusing at first, because if you look at how OpenTelemetry logs are represented in Loki, it's basically a JSON representing all the fields that you get from OpenTelemetry. So if you look closely, you see that the actual log message is there in a field named body, right? You also see that interesting other data is in there, like there is a trace ID, for example. This trace ID is used to render a link where you can jump to tempo and then search for the traces that were active in the context of this log and so forth, and a couple of useful other information. So it's cool that you have all this information available, but this is obviously not very cool for reading logs, because you would always need to look for where the actual body is. And the way that this is supposed to be used is in combination with the LogQL, so the Loki query language. So you can basically say, I'm going to paste this through a JSON parser, and then I'm going to create a line format, and maybe in the line format you say, I'm just going to use the body and I'm not interested in any of the other fields. And if you do that, it looks a lot more familiar. Now you just see the message body and you can basically just read through what happened, right? And this template language here, it's basically Go templates. It's pretty powerful. So we have a person at Grafana who made a template that resembles the exact same output that Spring uses on the terminal. So if you want to see the exact same output that they use from Spring terminal logs, you can copy a huge template from our documentation, and then it looks like that. Anyway, so that's how you work with logs. Cool. Now, time to wrap up and time to come to some kind of advice. So I showed you different options. You know, Java application, you can attach the agent, you can use OpenTelemetry API, you can use Spring API, and so forth. So which one should you choose? So what's the way to go? And of course, as always, it's not, answers, it depends, I guess. So there's one advice that doesn't depend on anything, because I can always advise this. It's a good idea to expose your business logic along with automated data, right? So it's always, if you understand what your application is doing, that will help you a lot with debugging, right? But then which API should you use, or which technology should you use? The first thing you should do is you should test it with your own application. So what I used in this example was a Hello World REST service. And of course, that's well supported by the OpenTelemetry agent, and that's well supported by the new Spring Boot actuator and stuff like that, right? But your application probably has a lot more dependencies and maybe something that's not so common, right? Maybe you're using a NoSQL database and some kind of reactive driver for accessing that, and try it out. Maybe you figure out that the OpenTelemetry agent is the only tool that gives you reasonable metrics for that, right? Or maybe the other way around. Maybe it's only supported by Spring Boot actuator and the OpenTelemetry agent gives you nothing, right? And if it's important for you to monitor these database accesses, maybe you don't even have a choice. I mean, the best idea is choose whatever works for your specific application, right? And if you end up with, in the lucky situation that all options work and you can really choose, I think it's a bit of a matter of what your future plans are. So the main differences then would probably more be the little things like how exactly metrics are named and so forth, right? And the thing with metrics names is that in OpenTelemetry they are standardized. So the name HTTP server duration will not only be used in Java if you monitor your Python application with OpenTelemetry or your Node.js or whatever. They all will have a metric named HTTP server duration, because this metric name is part of the OpenTelemetry standard. To be fair, it's not there yet, so it's still renamed a couple of times and attributes change and so forth. But if you think half a year from now, I think it will be there, and it will be really consistent across different programming languages, across different frameworks. And if your plan is to have reusable dashboards that do not only work for Java, for your Spring application, but that also work for other technologies and so forth, I think it's a good idea to go with OpenTelemetry naming. because this will standardize across a wide range of technologies, right? The other consideration is, of course, this nice native mode with micrometer. So if your plan is in the future, at some point you want to upgrade to Spring Boot 3 and then have a faster, startup at runtime and less memory footprint and, smaller Docker images, and you want to run your application in native mode, then you will not be able to use OpenTelemetry anymore because you don't have a JVM. And if you build your dashboard based on Spring Boot actuator metric names, then the dashboards will still work because the Spring Boot actuator is part of Spring Boot 3, right? So that's basically the considerations, right? And hopefully in the future, maybe Spring will also pick up OpenTelemetry semantic conventions and align on the same metric names, and then it will really not matter much anymore. Cool. So that was my overview of OpenTelemetry for Java developers. I hope it was useful for you. If you want to see the example code or a Docker Compose file with the demos that I showed you, it's up here. And yeah, have a good rest of the conference. Thank you. It's time for question? I don't know. You need to tell me when I stop, when I have to stop. Yeah? Mm-hmm. Ah, okay. Yes. So the yeah. I did. So the question was, just to repeat it for the recording, there's a person who tried this but had issues linking from traces to logs. So that was the direction here, right? So let's see. Then let's go to so where you configure this is in the data source. So data source, tempo is the trace data source. I'm not sure if I enabled this in this example here. Yeah. So this is how it's done. So basically, if you want to go from traces to logs, it's a configuration in the tempo data source. Then you have this traces to logs section here. You say where is your log data source, and then you say which tag has the will be used for the filter, and where is your trace ID. I'm not sure if I configured that correctly here. So I think if I just say service name as job, then if you link from traces to logs, you will basically see all the logs from the same service in the same time frame. And you can also and filter by trace ID. That's also enabled. Okay, so I think that should work. And the configuration is actually here in the tempo data source. Yes, the Grafana starter gives you logs, metrics, and traces. For logs, you still need the log4j or logback configuration, of course. Yeah. Cool. So thank you. I think I'm going to wrap this up now because the next speaker is in 11 minutes. Give them some time to set up. But I'm here, so I will hang around if there are some more questions. Thank you.